So this is our problem. Find the minimum value of z is equal to minus x1 plus 2x2 subject to the constraints minus x1 plus 3x2 less than or equal to 10, x1 plus x2 less than or equal to 6, and x1 minus x2 less than or equal to 2, and this constraint is a non-negative restriction. So they have given a problem. Now we have to solve this problem by graphical method. So this is equation number 1, 2, 3. So whatever the constraints, you have to take this equation in equality. So the first equation implies minus x1 plus 3x2 is equal to 10. Now you have to put x1 equal to 0. So you will get a point of x2. So this becomes 3x2 is equal to 10 and x2 is equal to 10 by 3. So now I will get one point. So that point is a 0, 10 by 3. Now the same equation you have to put x2 equal to 0. So that time you have got minus x1 equal to 10. So this implies x1 is equal to minus 10. Okay. Therefore the corresponding point is minus 10 comma 0. Minus 10 comma 0. Okay. Next you have to take a second equation. So next you have to do the same thing for the second equation. Take the second equation. Second equation is x1 plus x2 is equal to 6. Put x1 equal to 0. Put x1 equal to 0. We get x2 equal to 6. So therefore point is 0, 6. And now you have to put x2 equal to 0. So this implies x1 equal to 6. So now the point is 6, 0. Do the same thing for the third equation. Third equation is x1 minus x2 is less than or equal to 2. So here if you put x1 equal to 0, so this implies minus x2 is equal to 0. So taking equality here. Equal to 2, that is x2 is equal to minus 2. So the point is 0, minus 2. And x2 equal to 0. Put x2 equal to 0. This implies x1 equal to 2. So therefore the point is 2, 0. And this is a non-negative constraints or non-negative restriction. We have to omit this negative point. Okay. So in this graphical method, we have omitted the negative points because this constraints always positive. So we have omitted this point, this and this point. For this point only, I have plotted the graph now. So now I am going to plot the points in this graph. So I am taking a x as a x1 and y as the x2. So the points are up to 10. So I put one unit is a 1 centimeter like this. So now the corresponding positive points are first equation gives 0, 10 by 3 and minus 10, 0. So the 10 by 3 is nothing but 3 point something. So 3.33 I just take here. So this is a 0, 10, 3 points. If x-axis is 0 means this point lies in the y-axis, that is x2 here. So x2 axis. So this is the corresponding point. And the corresponding equation, another point is in the negative side, that is in the minus 10. Minus 10 is this side. So if you plot that line and joining that two lines, this line goes like this. So it is a imaginary. So this line goes like this. So I consider only the positive direction. So this is a straight line occurs by the first equation. What is our first equation? Minus x1 plus 3x2 is equal to 0. So here we have to take equality, so I am using this also. So in the second equation, the points are 0 comma 6 and 6 comma 0. So 0 comma 6 is this, and 6 comma 0 it is in the x-axis, that is x1 axis. Now I am going to join these two lines. So you can use a scale to join this points. So this is a straight line occurs by second equation, that is x1 plus x2 equal to 6. What is our third equation? Third equation is 2 comma 0. 2 comma 0 is this point, and minus 2 comma 0. Minus 2 comma means this one is minus 1, this one is minus 2. That means this point. So the for this two equation, this 2 point I am going to join, and I extend in the positive direction only. So now I am ignore this area because it is a negative side. I just ignore it because I need the straight line, that's why I put the point here. So now I'm going to find the bounded region. So I'm going to check the solution part in this graph. So always in the x1 x2 is a positive direction, or in the first quadrant non-negative restriction. So this should be in the positive direction. So you have to shade like this in the small lines like that. Now I got the bounded region. So this one is bounded region, but we have omit this region, and this one is bounded region, this one is bounded region, this one is bounded region, and these are also some other region I got. But I am going to check which region got have the feasible solution. For that I have a trick on that. So this is a third equation. The third equation is x1 minus x2 is equal to 2. Okay, so I am going to check now in the constraints. In our original constraints, you have to put x1 equal to 0, x2 equal to 0. That means 0. 0 is less than or equal to 10. Is it true? Yes, it is true. True means you have to shade, you have to shade. Which one is the first equation? This is our first equation, correct? So true means we have to shade facing to origin. So this is our origin. You have to shade the equation and which face the origin side. So the origin side you have to shade like this. This is a technique for finding the bounded region. That's why I am shading this. Okay. And you have to check the second constraints. What is our second constraint? x1 plus x2 less than or equal to 6. Same technique, you have to put a x1 0, x2 0. Here 0, it become a 0. Whether 0 is less than or equal to 6 or not. Yes, it is less than. So this is also true. And the third one also true. If you put x1 0, x2 0, this is also true. So 0 less than or equal to 2. So this is true statement. So for the three constraints, I have shared facing the origin only. And this is a second equation, and the second equation is true, and we have to shade facing the origin side. So this is the origin side. So I am going to shade this region. This region. Okay. And this is the third equation, and the third equation also true. True means I am going to shade towards the origin side. So this is origin side, towards the origin means this side. So now I am going to find which is our bounded area. So I have got three bounded region in the first quadrant. So I am going to check here. So if you put one dot here means this shades are seeing in the dot. You have to check that. So this is facing the dot, this is facing the dot, but this is not. So it is not a bounded region. and if you put here means all the sides are facing the dots, or if you put this pen means all the sides facing to the nip of the pen. So this is our bounded regions. Likewise you have to find the bounded region, and this is a bounded area, so that is called a bounded region. So our solution lies here only. So this is also another one region, but here the shading of this line goes opposite, so it is not our bounded region. Here also the same thing. So this is a bounded region for our problem. So I put the some name. This is origin, so I make this as a O. This is A, B, C and D. So I know the point A. A is nothing but 0, 10 by 3. 0, 10 by 3. B I don't know. C I don't know. And D no. So I know. So which is 2, 0. So therefore the extremum points, the extremum points of the feasible solution. So and this bounded region satisfies all the constraints. So this is our feasible solution also. So this feasible solution lies in the bounded region. So the feasible region, the points are origin first, origin that is 0. I put this as a 0, and A is the point what, 0, 10 by 3, and B I don't know, I am going to find this, and C I don't know this point, and D is the point 2, 0. So now I am going to find this 2 point using the elimination method which we have learned in the school days. So you have to check for which two line gives this point. See, this point occurs by intersecting first equation and second equation. So I am going to solve this two equation by a elimination method. I will get the value for the points. Okay. So first equation is minus x1 plus 3x2 is equal to 10, and the second equation is x1 plus x2 equal to 6. Here it has a same coefficient and with the opposite sign. So I just eliminate this. I just add this to equation. So it will cancel using the elimination method. That's it. So this is 4x2 is equal to 16 and x2 is equal to 4. So the corresponding point, you have to substitute x2 is equal to 4 in any one of the equation. So that if you put this equation, and x1 is equal to 2. Therefore the point P is equal to 2, 4. So I found that point. So likewise I am taking the I am going to find the point C, and you have to check again. This C is the point occur by intersecting second equation and third equation. Now you are going to solve this two equation. So what is our second equation? Second equation is x1 plus x2 is equal to 6, and what is our third equation? Third equation is x1 minus x2 equal to 2. So x1 minus x2 is equal to 2. Same here, x2 having the opposite sign. If you're not having the same coefficient, you have to make that as a same coefficient. After that you have to use the elimination method. So here it is a negative opposite sign. So I just cancel this, adding this two equation, it will be cancelled, and 2x1 is equal to 8 and x1 is equal to 4. So you have to substitute this here. So this becomes 4 minus x2 equal to 2. So minus x2 is equal to minus 2 and x2 is equal to 2. Therefore the corresponding point is, that is C is 4 comma 2. So now I got all the extremum points. Now I am going to check which point it occur the minimum value. So this is our extreme points and this is our optimum. Z is equal to minus x1 plus 2x2. So first one is origin. Origin is 0 comma 0 and next is A. A is 0 comma 10 by 3 and B is just now we found that point 2 comma 4 2 comma 4 and C is 4 comma 2 and D is 2 comma 0. So I am going to put all this point here and for x0 0 it become a value 0 and for this point it become a 0 and 0 plus 2 into 10 by 3 it is 20 by 3. So 20 by 3 means it is approximately 6.666 etc 67. Okay, and for this it is minus 2 plus 8. 4 2s are 8. So this is nothing but minus plus 6. Okay, and here it is minus 4 and 2 into 2 4 plus 4 it become a 0. Again it become a 0 and 2 it is minus 2 and this is 0. So that is minus 2 plus 0 which is minus 2. So now I am going to, in this problem they have given a minimum value. So minimum value means you have to pick the minimum point here. So for which value I got a minimum value. It is 0, 6.67 plus 6, 6 minus 2. Which one is minimum here? Minus 2 is minimum. So therefore this feasible solution or this optimum solution is minus 2 and which point in x1 is equal to 2 and x2 equal to 0. Therefore the optimal value is minus 2 at x1 is equal to 2 and x2 equal to 0. So this is our answer. Thank you.